attempt to use my indoor voice so I don't blow out the mic. How are we doing? Good to go? All right. Excellent. Thank you all for coming. My name is Kevin Bonham, and along with my co-presenters, Annalee Harris and Elwin, I'm not going to try to pronounce your last name, as well as a couple of people who are not here, Gracielle Hingino and Henri Lurie. We are recipients of Julia Diversity and Inclusion grants. We all wrote separate grants and got funded, and so three of us are here to present our work to you today. And then at the end of this session, we hope to sort of solicit feedback from all of you to see if you guys have other ideas for increasing diversity and inclusion. Obviously, you know, the five of us are not going to do this by ourselves. This should be a community-wide effort. And so we've got our little niches, and we would like to expand it and help everybody out as much as possible if we can. So just a little bit of a background on the grants. So these were, I think the call for abstracts went out late last year, and these were funded by the Sloan Foundation through Julia Computing, and there were $15,000 of awards in total, and the call for abstracts was for projects that will increase the diversity and inclusiveness of the Julia community. So the outline for the talk as a whole, first I'm going to talk about my project for increasing women, the representation of women in computational biology. And then Anna is going to tell us about using JuliaBox and peer-led team learning to enhance minority STEM majors' math performance. Elwin is going to tell us about raising diversity and inclusion among Julia users in Chile. And then we'll have a couple of slides about Gracielle's project on a small Julia user study group in Brazil. And Henri is developing a MOOC. And then, as I said at the end, we hope to have a discussion and solicit ideas, and hopefully maybe, form some connections of people that are interested in this topic and can help each other out. So first up, I'm going to talk to you about increasing the representation of women in computational biology. So here's an outline for my talk. I'm going to tell you a little bit about myself so you sort of know where I'm coming from. My background is in biology. I'm not a computer scientist by any means. And then I'm going to tell you a little bit about the background of why I think there's underrepresentation of women in computational biology, some research I did a couple of years ago, and why that's important. And then finally, I'll tell you a little bit about the project that I got funded to produce a course for teaching introduction to computer science to biology students at an all-women's college. So first, that's me. That's my GitHub profile picture that you might recognize. So I got my PhD in immunology in 2014. That's the title of my PhD thesis. It's sort of completely unfamiliar, I'm sure, to most people in this room. It seemed really important at the time that I defended, but since then, I've done a couple of different things, all biology related. For my postdoctoral work, I taught in a master's program in immunology, but my research sort of started to move into computational biology, and so I'm a self-taught programmer. I actually started with Julia circa version 0.3. I know this because I went back and looked at my very first Stack Overflow question and was using Julia version 0.3. A friend of mine that was in a PhD program at MIT, when I was asking him, like, oh, what programming language should I use? I don't know anything. And he was like, oh, there's this really cool new language called Julia. You should try. And so I was naive and tried it, and it was way too hard. There was not enough stuff online, and so I switched to Python. But then I came back to Julia later on in my postdoc, and I've been doing basically exclusively Julia programming for the past year and a half or so. The work that I've been doing for the past couple of years is primarily human microbiome research. So I study the microorganisms that live in your gut. My specific research, I think, is really interesting, and if you're interested, I'm happy to talk about it over a beer, but not going to talk about it at all today. Basically, what I'm doing with Julia is essentially data science. I use data frames, I use the stats packages, and a couple of other things. But that's primarily what I do in code. my job, I'm a research scientist at Wellesley College. This is an elite all-women's college in eastern Massachusetts, in Wellesley, which is just outside of Boston. And I'm the primary author of microbiome.jl, which is basically just a wrapper package for a bunch of other tools that are useful in microbiome research. It's part of the BioJulia ecosystem as a whole. So that's me. That's how I came into this. A couple of years before that, I got really interested in this topic of women in computational biology because, well, for a number of reasons. But first, I want to sort of give a little bit of background about women in STEM fields in general. So STEM, if you don't know, the acronym is science, technology, engineering, and math. And we know that women are underrepresented in STEM. I'll show some data about that in just a sec. But the potential causes of this are sort of, they're legion. There's a lot of them. And here's sort of a small, non-exhaustive list. So undergraduate students, we know, show bias in favor of men, both when rating their peers and their professors. Professors are more likely to respond to emails from male students, and they show gender bias in hiring decisions. Women publish less than men. They're underrepresented in more prestigious author positions. So in biology, the first author is the person who did the work, basically, the graduate student or postdoc. The last author is the corresponding author, basically the principal investigator of the lab. And women are underrepresented in both of those positions. They also publish fewer single author papers in all STEM fields. We know articles by women are cited less than those authored by men. Possibly one of my favorites on here, favorites, is because men cite their own work more than women do, which may be part of the reason for the prior thing. We also know that when women do work, it is more likely to be attributed to a male colleague. This is kind of interesting that if you look at the biographies of successful female scientists, they tend to be filled with gender stereotypes compared to male scientists, where the stories are about their specific discovery, or they're about some interesting thing about their background. Stories about even very successful women scientists, they tend to perpetuate female stereotypes. And then finally, male scientists are less likely to accept studies that talk about gender stereotypes. So you have all of this evidence, and yet men they look at all this evidence and they're like, yeah, probably that's not true. So there are a lot of reasons, and this is a non-exhaustive list. If you're interested, all of these citations are from a paper I published a couple of years ago on computational biology that I'll be showing some data about later. That'll have a link if you're interested in reading up on that. So one of the interesting observations that sort of got me interested in this is that though women are underrepresented in STEM fields, the degree of underrepresentation is not the same across different fields, right? So this is data published by the NSF. They do these surveys on diversity and inclusion every couple of years, and they track not only gender, but also underrepresented minorities, gender identities, and other backgrounds. And so on the left, you can see, it's a little bit hard to read, I think, but basically, at different levels of education, bachelor's on the bottom, master's degree and doctorate, you can see that at the bachelor's level at least, for the past 20 years, women have actually been a little more than men in terms of the number of bachelor's degrees awarded in biology.
Sorry, can you explain what's on the left of the
Oh, sure, sorry.
the right?
Yeah. So, am I still picked up by the mic if I move over? No? Okay. Well, I'll just gesture. So the bars to the left are the percent of women. So the numbers there, if you can't read them, are 20, 40, and 60 on the axis. And then to the right of the axis is the number of women in thousands. So I didn't produce these graphs. These are from the NSF. The link is here if you want to look in detail. But basically, at the bachelor's level, in 2016, 54.8% of bachelor's degrees in biology were awarded to women. It's been steadily increasing, slowly but surely. It's also been increasing at the master's and doctorate levels. This is a common phenomenon that as you go up the sort of academic ladder, representation decreases, but it's pretty decent in biology and has been actually for the last 20 years or so. Computer science is on the right, and hopefully it's obvious that it is kind of abysmal. And I think one of the things that is most troubling, maybe I can use the mouse over here. One of the most troubling things is that it's actually been decreasing at the bachelor's level. So the number of women getting computer science bachelor's degrees has been decreasing over the past 20 years. And this is actually continuing a very long-term trend. The number of women in computer science peaked, I think, in the mid-1970s, and then has been steadily declining as a percentage of the overall workforce since then. And the decrease hasn't been quite as dramatic at upper levels, but the numbers are pretty bad. So you can see, where's my pointer? Here, so the number of computer science PhDs awarded to women in 2016, read it there, is 20%. So we have this general underrepresentation of women, but it's different across fields. So one of the things that I got interested in a couple of years ago was, what is it like in a field that is a sort of hybrid of multiple fields? So computational biology combines computer science and biology, so how does it look in that field? So if you have one of these cross-disciplinary fields, what does gender representation look like? So my colleague Melanie Steffen and I looked at publications from a giant database of biomedical literature called PubMed, and we took all of the papers published from 1997 to 2014, and articles on PubMed are indexed by these things called medical subject headings, or mesh terms, and those are manually curated. So someone at the National Institutes of Health is going through every research paper that's published and manually adding these different categories to them. And so the reason we started in 1997 is because that's when the computational biology mesh term was started. And so we looked at basically all of the computational biology papers that have been published in the last 20 years and compared them to the biology papers that were studied. And we looked at the gender of the authors, and we inferred the gender using this online tool. There's a couple of different ones in a bunch of different languages that you can try. This is an API that we used. And so this is what we found. So basically, we looked at different author positions, and we looked at biology journal or biology papers versus computational biology journals, and we asked what is the percent female authorship, inferred gender based on their first names, at each of these author positions. And what you can see is uniformly across all author positions that women are, we don't have equal representation at any author position. Computational biology is uniformly less than biology papers as a whole. This trend has been steady over time, so we can look at publications by year and see that basically computational biology is continuously under that of biology. And again, sort of as expected based on other trends, you can see that the last author positions, which are again those senior author positions on biology papers, there's lower representation of women, both in biology and computational biology. I think the main story here, though, is that it's not actually that much worse than biology as a whole. So we have these papers that are published that are using computer science in the biology domain, and yes, there are fewer women publishing papers, but it's not, it's not the 20% that we see in terms of PhDs in computer science. And actually, if you look, I have data that I don't think I put in here. When you look at computer science papers from Archive, which is not an exact comparison, but it's something close, basically the percentage of female authors is like in the 10%, 10-15% range. It's really terrible. So I think this is sort of good news that computational biology is not like way down. Yeah?
Is this adjusting at all for the lower rates of graduate degrees among those?
No, this is just looking at overall numbers of papers published at the different author positions.
So they could actually be more productive than they're.
Oh yeah, in terms of productivity, certainly, yeah. That's a really good point. One of the things that I'm interested in, we were interested in doing, but we didn't have time to do it. It was basically to see if we could look at GitHub contributions and see if there's a relationship between the amount of work actually done and like position on papers. I'd like to do that in the future, but it's hard to link GitHub IDs to names on published papers, and so we didn't spend time on that, but that's an interesting question. Another thing that I think is maybe not surprising and potentially hopeful is this. So here, taking the same data and separating it into papers where the last author is a man versus the last author is a woman, and then looking at the other author positions on those papers. And basically, again, we see the same trend comparing biology to computational biology, but if the last author is a woman, basically all of the other author positions are much more likely to be women. So it suggests that there's some mentorship effect, right? If you have more women in senior positions, they are more likely to have women on the papers that they publish. And there's, the sort of causal direction of this is, there's a lot of different ways you could interpret this, but it's potentially interesting question.
So I understand the different fields have different conventions with regards to like the person who contributed the most being cited in a certain order.
Yeah.
Is it the case that the last person would be the most senior or the most involved person in
So computational biology and biology tend to be very similar in terms of that convention. Yeah. And the seniority is sort of, it works in from the outside. So I wouldn't necessarily call the PI the most involved. They're the person that paid for it, right? The senior author is the last author, the corresponding author, the person that you contact, the person who runs the lab basically is the last author. And then the second to last is if there's a collaborating lab, that'll be the principal investigator of that lab. And then the first author is the person who actually sat at the bench and did the work, or at the computer, and then it works in from there. So basically, middle author positions are more or less useless, and then the outsides are the interesting ones. I say that as someone that is a middle author on a number of papers, so...
You just made me feel worse about my paper.
I'm so sorry. The paper I published most recently, I am like dead center in like a list of like 50 authors. So it's fine. I did work, and that work was validated. So one interesting thing is we looked at different impact factors for these journals. For those of you that don't know, this is basically a measure of how often papers from that journal tend to be cited. It's a terrible metric for a number of reasons, but people care about it. And basically, there's not a huge effect of impact factor. There's a small trend. And this is actually sort of confirms previous work that in some fields, women are actually more likely to publish in high-impact journals, and in other fields, women are actually less likely to publish in high-impact journals. So there's a little bit of a mixed story there. But basically, in our data set, there didn't seem to be much of a difference. This is the data I was mentioning before. So computer science is substantially worse. We tried to use, there's a tag on arXiv called quantitative biology that is, I was trying to think is like the most direct comparison, but it's not a great comparison. It's a little bit better than computer science, also quite bad in terms of papers published in arXiv. So again, you can't really compare this to the PubMed data set, but yes.
Have you looked at bioRxiv?
Have not yet looked at bioRxiv, so I actually am thinking about doing a follow-up study.
Because at least, I mean, I think many people who would consider themselves primarily biologists would never have published in arXiv.
Absolutely.
I guess you're deliberately trying to use this as a sample of computer scientists rather than a sample of biologists.
Exactly. And at the time that we were doing this work, bioRxiv didn't have that many papers.
Right.
In the last 5 years, it's totally exploded, and there's a ton of so we definitely, and a lot of computational biology is being published in bioRxiv. So we definitely plan on looking at that next. Yeah.
This last 6 months or so, or a year, I've been spending a lot of time with people doing computational pharmacology.
Cool.
So what Chris is into now, the QSP.
Yeah.
And it seems they have a very large representation of women.
Oh.
And I wonder if you had looked into that at all, because that's also kind of like a cross with...
Yeah, totally. No, I have not. That's interesting to note. So the question was about computational pharmacology, and the observation is that maybe there's a better representation of women in computational pharmacology. I don't know anything about that. That'd be really interesting to look at. I have a friend that was interested in looking at using a similar method, looking at linguistics and computational linguistics, as opposed to like the social science one. all of those I think would be really cool experiments. If you're interested, let me know. I'm happy to talk about our methodology. And I think more research of this sort would definitely be valuable. So anyway, this is all background. This is from a paper I published a couple years ago. There's a GitHub repo with the code. It's Julia circa 0.5 or something like that. And the paper's on PLOS Computational Biology. So this brings me to the project that I wrote the grant for, which is an intro to computing course for biologists at a women's college. And so the idea behind this project is that if we introduce a different framing to learning computer science, that we might sort of short circuit a number of the biases that go into decreasing women's representation. And so one of the things among many is that often computer science courses are framed in terms of abstract math and logic. They focus on things. Examples are from male stereotyped interests. And so the idea of this course is that if we instead use real-life biological problems, focus on people, and take examples from biology and ecology, that we might, what's the right word? Sort of get around some of the typical stereotypes that prevent women from thinking that they would be interested in computer science. And so I proposed to produce a course, Introduction to Computing for Biologists, and I would love if you have a splashier name, because curriculum committees at colleges really like splashy names. Something that has the word omics in it would be really awesome. And these are the learning objectives. You'll notice that basically most of these are not biology-related learning objectives. It's about learning computer science. But again, the idea is just to change the problem sets that we use to teach the same sort of fundamental concepts that students might learn in a computer science course, with a few additions, such as explicitly teaching command line, explicitly teaching Git version control. And the reason for that is because I have noticed that among my biology colleagues, some principles of software production that I have sort of learned being part of the Julia community, with its emphasis on unit testing and version control and all of that, which I now find to be amazing. Most biologists basically know nothing about that and don't seem to care much. And so my idea is if I introduce it from the ground up, then we can sort of bootstrap a cohort of awesome female computational biologists that are going to be, way better than their peers in terms of all of these things that make code better that most biologists couldn't give two craps about. So these learning objectives, the plan is to use GitHub Classroom, which, if you're not familiar with it, is a neat sort of system that GitHub has built in, where you can sort of produce a template repository that has an assignment embedded in it, and then you enroll students into your GitHub Classroom. When you make an assignment, they clone the repository. They have their own copy that is owned by the classroom organization, so that you still have write access and things like that. And so you can observe what the students are committing, and you can make, I don't know if you can...
Can you say a little bit more? I kind of
Oh, sure.
missed this, what this GitHub Classroom thing is.
So it's a...
So it's not public, so if you give out homeworks and stuff, those things don't become public.
So you can make it you can make it public or private, and so if you have an academic email address, GitHub will give you unlimited free private repositories, and that includes organizations that are part of classrooms like this. So you can have all the students have private repositories. You can have template code that you give them that has the assignments or has the the lessons and everything embedded in it. And then the structure is that you produce a lesson repository or an assignment repository. The students clone that repository into their own GitHub account, but the remote is in the GitHub Classroom organization. So I have this Wellesley 195 testing organization, and so any student that clones from that template repository is pushing to a repository that's in this. It's just their own separate instance of it. And it's private to them, but I can see it. And then one of the great things about this is that you can basically write assignments as Julia code and then integrate that with things like continuous integration and test sets. So for example, in my second lesson, it's about sort of types and functions. And so as an assignment, this is just a draft, but basically like ask them to assign variables that have different types and then have them write a simple function. And then I can write a test set that says, did they actually do that? And the student, as they're working on the assignment, can run the test suite themselves or push it to their repository and have Travis do it automatically for them and get failing or passing tests. And then, so they're getting, thank you. So they're getting feedback without me having to go in each of their code sets and say like, what did you do wrong? They're getting feedback from the test set, if you design it correctly, that sort of allows them to get lots of iterative work, which, as I'm sure most of you appreciate, problem solving, banging your head against problems, looking for solutions, is part and parcel of coding. So, and one of the explicit learning objectives of this course is also learning how to look online for resources. You would be shocked at how reticent students are to go and look for answers online. They think that if they either need to have it memorized or they need to go to the professor to ask the question if they don't understand. They're very reluctant to search for answers on their own. Yes?
So for a typical student, like I get my first homework assignment and I'm a newbie and I'm like, I have to do this thing online and just like, it needs to print hello or something.
Yeah.
And it's like, oh, I didn't get a string back, so it's wrong.
Yeah.
And then like I might like just try and monkey hack my assignment.
Yeah.
I'll turn it in and it will luckily just be the like what it has to return. But afterwards, can you reveal the tests that they passed or they didn't? Because I'm not so. It might come later, but from this you can just try and like arbitrarily put code in it until it passes tests, which isn't the same as like trying to like build your functions and your modules.
Yes.
And then, like do a unit testing.
Yeah, that's a great point. So the question is, can you just sort of like hack your way to passing tests without actually thinking deeply about the code? I mean, my thought is if I design the tests properly, that should be difficult. If students are able to look at the tests, figure out how to pass the tests based on that, honestly, I think they've achieved the learning objective. Like, if they're able to like look at the code and figure out how to like, that's enough for me. I'm not planning to make any of this like, what's the word? Like, I'm not going to hide anything from them. I'm not planning to, like, the test sets are going to be part of the repository. They can go look at the tests and see what's there. And if they can use that to help solve their problem, that's fantastic. That's sort of what the goal of this is, that they can look, they can read and understand code, they can try to solve novel problems, and whatever way they're doing that, I would be totally fine with. So this, I think in other situations, if you're running an, like, a normal computer science course for CS majors that are maybe like slightly more sophisticated and could, sort of like cheat their way to it, you might have to think a little bit differently. But in my case, if they can, quote, cheat, as long as they're not taking their friend's code and pasting it into their own repository, I'm fine with whatever other way they're getting to it. Yeah.
I mean, just to elaborate on that a little bit, I mean, for the simple example here, seeing your tests, those are, more complicated than actually getting the right answer there. So, of course, if they look at your test, they'll probably learn more than
Absolutely.
if they just did the assignment, right? But I mean, later on in the course, you might get to something like how many P450 genes are there in the human genome, right? And if they look at the tests and see that the answer is, 273, they could write a function that just returns 273. Right?
Yeah, so what I would probably do, and I have started to think about that. I haven't actually written any examples of that. My plan is to, for something like that, basically write a separate package that has the code that does the calculation, that then at the top of the test it'll say using, assignment 4 background code, and we'll use that to generate the answer to the test set. And in that case, so like, I'm not going to say like test, test does this equal 42? Like, that's obviously not a super useful test. But if instead I have some sort of code that obfuscates how that answer was generated, then again, if they're able to look at that code and figure out what the answer is from that, then more power to them. I'd be happy with that result. And by the way, I didn't say it explicitly, but I'm very happy that people are asking questions in the middle of the talk. That's my preferred way to do this. I don't know if Anna and Elwin feel the same way. But so then the next step, so there's the step of building this course, and I'm going to teach it at Wellesley College, which is an all-women's liberal arts college. So, right there, that's like increasing Julia diversity. If you looked around the auditorium as I did today, you might have noticed that we have a rather significant lack of women in the community. But so that's one thing. But the next step, I think one of the things that I'm most interested in is to say, can I then use this students that take this course at Wellesley and potentially at other institutions to also measure whether my hypothesis, this like idea of differential framing, is actually doing anything. And so I'm planning to design assessments that look at how students feel about their own competence and ability to master computational skills. How confident are students in their ability to solve problems with computers? So this is sort of a simple question, but a lot of students lack confidence in their ability to do stuff like this. And then, of course, we measure before and after the course, see if those have changed. One of the things that is also quite interesting is how closely do students' perceptions of their abilities track their actual abilities. We're going to have a ton of data from all of these lessons about how well students are actually learning the things that they're learning. And so if they're not very confident in their skills, but they have a lot of skills, that's interesting. Also, if they think they're really good at things, but they don't have the skills, that's also interesting to know. And then, are these things different between men and women? So there are a number of institutions that are sort of like sibling institutions to Wellesley College. And so if we take this course from Wellesley to other co-ed institutions, are there meaningful differences in these measures between men and women? And are there meaningful differences in these measures between women at all-female institutions like Wellesley and those at co-ed institutions? A lot of the things that I mentioned in terms of biases that affect female representation are things that are in some degree dependent on male students next to them, right? So if you're in a class that's co-ed and professors are more likely to call on male students, then that's going to not have as much of an effect if you're at an all-women's institution. So I'd be interested to know, are there differences between these things? So future directions, the plan originally was to teach this course this summer, but Wellesley is doing this whole refit of their science center, and so they had to cancel a bunch of courses because things are behind, and mine was one of them that got canceled. So the plan is to design it in the fall, teach the first iteration of it in spring of 2020, and the funding that I got from the grant is going to be used to pay a student to help me develop and beta test the course, and then pay for a student to TA in the spring. And then from fall to the future, the hope is to try to do this course at other institutions, not just Wellesley College. I have a friend at Smith College, which is another all-female institution, and some colleagues at Harvard and UMass. So the plan is to look at a couple of different institutions and see if we can do the same thing there. Analyze these survey data. I used the word analyze twice there on accident. Apologies. And that's it for me. So if anybody has any other questions, now I'm happy to answer them, or we can move on to Anna. Yeah.
So this approach takes the principle that there is a systemic problem of diversity, and particularly women in STEM. And one way to try and fight it is to try and go to the individual women and give them either the tools or the support and the help so that they can keep on making individual progress towards entering STEM. Have you thought about flipping that narrative and saying, why are we systemically pushing out women from STEM in the first place and not burdening individuals with like overcoming systemic problems?
Yes, so that's a great question. So just for the recording, the question is about the difference between this approach, which is saying, okay, we have this underrepresentation problem, let's get individuals to learn computer science or whatever STEM discipline and get them to basically help us in STEM fields to overcome this diversity problem, which is really putting the burden on the people who are underrepresented and potentially disadvantaged, as opposed to coming from the top-down approach and saying, like, can we address the problems of diversity in the communities, alter the way that we behave towards women in ways that push them out of STEM pipelines, so that it's not, the burden isn't on the individuals to sort of help with diversity. So it's a great point. It is absolutely an important consideration, and I think that attacking the problem from all directions is worth doing. Whether one is more effective than another, I don't know. I'm not. I don't have great ideas for how to address top-down. I think a lot of people are doing that work, and I think it's great. I don't have anything novel to add to that. I support those efforts 100%. One of the thoughts behind this approach is that we can see and potentially infer that there's a self-fulfilling prophecy aspect to this, which is that if you have fewer women that make it to professor positions, you have fewer examples for younger women, and we know that examples of people doing this work can be a way to overcome some of those biases. And so one of the ideas here is that if we get more people through the front end of the pipeline, we will get more people at the end. This is obviously a long-term strategy, and it suffers from the problems that you rightly point out. But yeah, I think.
Yes, like no one solved this that I know of.
Yeah.
Like in the history of ever.
Yeah. Clearly, we still have this problem, right? Yes.
First, thank you for a wonderful presentation, very informative. Sort of very much following up on that line, actually my understanding, and I wish I knew the details and I don't, but I maybe it'll be useful to someone following it up, or I will someday, something. But my understanding is that this is not very evenly distributed across institutions. And one story I heard was my alma mater, Rice University. You know, it's a well-known place for learning to do comp sci. A few years ago, they restructured their curriculum, and they went from something like 15% female to 40% female in the undergraduate major for computer science.
Because of the curriculum change.
Because of the curriculum change. And,
Wow.
and I don't know the details of what they did, but that's
I really hope someone is studying that.
Sounds like a remarkable success story.
Harvey Mudd did that.
Is that right? Yeah.
And just, so they're up at like 50%. And it's like, I want to send my son there.
Right, yeah. No, absolutely, totally understood. So
Yeah.
there do seem to be, I mean, the fact that there are so many efforts is fantastic, and there do seem to be some success stories. So, I mean, I think I'm very optimistic that this is a problem we'll overcome.
Yeah.
But we obviously have to be very, cognizant of the barriers that we all face. In
Definitely.
getting there.
Yeah, I think that the, well, hopefully some mic picked you up. I don't think I can re-summarize that. Basically, at Rice, there was an effort to change the curriculum. Curriculum change resulted in a drastic increase in female majors in computer science, which seems very hopeful. I would be interested to know what the details of those curriculum changes are. I think some of the stuff that I'm talking about here is maybe related. So that this idea of, so the idea of the framing effect, this the most potent example to me was, there was a study that was done, I can't remember the details exactly. I learned about this in my fellowship, but basically looking at the effect of learning physics, right? We like to make sort of word problems in a lot of STEM disciplines that help people, we think, relate to the topic. And so they were looking at basically people in the United States versus people in India, and they made the physics problem about baseball versus cricket. And like, obviously the cultural context matters a lot there, but if you're a physics professor in the United States, you're going to make your physics problem about baseball. A lot of your students don't care about baseball, right? No matter how much you care about baseball, and it's going to help those subset of students potentially relate if it's about baseball, but if you use an example that is stereotyped to a particular group of people, whether that's a gender stereotyped thing or a cultural stereotyped thing like sports, or any of a number of other things, that will cause a problem in terms of a subset of your students learning that material. If it is true that using examples helps students learn, then if those examples are irrelevant to students, it's not going to help those students learn, right? And there's also evidence about like the names of the protagonists in your word problems, right? If you make all of the people that are trying to solve problems male names, then that's going to affect the feeling of inclusiveness for women in your study, or in your class. Yeah, so I think curriculum changes, great. It's really amazing to hear that that's had such a big effect, so that's promising. Yeah.
One of the things that I've learned, at least from listening to lots of discussions of this topic over the years, is that the problem occurs at basically every age. And, it starts...
And every interaction, yep.
Right, it starts with what toys
Yep.
are given, and then of course, in the workplace, like the Uber situation, things like that, it's a problem there. So the percentage that stay with it decreases as well. And so I sort of have two questions that relate to those other examples. When I hear things like, and I did read, Harvey Mudd, 50% women in computer science and these other strides, does that mean that our K through 12 education has really sorted things out and are doing a great job? That's sort of question one. And the question two is, does all these stories about what happens in the workplace feed back and push women out of computer science before they get there? I'm just curious to...
Yeah, I don't know, empirically I don't know the answer to either question. I think they're both good questions to ask. I suspect, well, there's two potential answers to your first question, which maybe I should repeat also, and tell me if I got it right. So one is, does the fact that a place like Harvey Mudd can get 50% women in computer science, does that suggest that actually it's fine in K through 12 education? And then B, remind me what B was again? What was the second part of the question? Does stuff filter? Yeah, does stuff from the job market, like negative stories from industry, filter back? I suspect the answer to the latter question is yes. I don't have empirical data about that. In terms of the first question, I suspect that to the extent that so most students aren't learning computer science in high school still, right? I think the problems probably come more in like math and physics in K through 12. And so it'd be interesting to see, like, could Harvey Mudd do the same thing with their math curriculum? Math is worse than computer science, by the way, if you look at the NSF data. Or if you look at high schools that are starting to teach computer science, does that actually cause problems if students are being introduced to potential stereotypes early on, if they're not being thoughtful about their CS curriculum in K through 12? But yeah, I don't know. They're interesting questions for sure. So I think with that, I think if anybody else has any thoughts or questions, maybe we can save them for the discussion at the end. Because I think we'll still have time, although I took way more time than I expected. Thank you for all those great questions. So next up we have Anna, who's going to tell us about using JuliaBox and peer-led team instruction.
Well, thank you guys for coming to the session. Actually, I did this because, when I saw this Julia giving out this inclusion and diversity grant, I thought this would be great because... Sure, sorry. And when I saw this, my husband looked at that, the advertisement showing that, they're giving out the grant for the inclusion and diversity. I was like, what? I think my school would be perfect because my school is 90% Black American. So, and also we don't really do any computer programming in our curriculum. I'm a math instructor. I'm a math faculty. I'm an associate math faculty. And I was like, this is great. But if I want to really use a computing in my math teaching, I feel like I need to do is like I'm working with my faculty, right? If I cannot teach all math classes just because I know JuliaBox, right? So what I did is like, you know what? If you guys fund me to do some work with my faculty, maybe I will train them. Maybe they can start working with me. So just like what I said, I'm going to just talk about my school. It's a HBCU, historically black land-grant institution in the state of Arkansas. And our school is established in 1873, and we have about 2,821 students, and 90% of them are African American. And like I have to do these things because, like, you know, whenever you do something because there's a problem, right? So the problem that we saw in our school is we're teaching a college algebra class. And then we have really, I know some of you guys do not even have a college algebra class in your curriculum, but we have a college algebra in our curriculum. Like, we have really, really high failing rate. The college algebra is required for all the STEM majors, pretty much. Like biology major, like we have a biggest STEM major in our school is a biology major. Okay, and then nursing is our second biggest. But they all have to take college algebra class. But we have like over 45% of failing rate, and it was increasing since 2017. So we got bigger major, biology and nursing major, but they're failing more. So we're thinking about like, okay, there's a problem, what can we do? Okay, must be we're not doing something right? You got so many majors who want to be a STEM majors, but they're not passing. They're not going through the process, right? So globally we have a problem because we don't have enough STEM majors, right? So we don't have enough STEM majors, so we don't bring out more STEM workers. Moreover, we have a more problem because we don't have enough minority STEM workers, right? I mean, not just the female I'm talking about, it's about, you know, like, you know, especially like African American STEM workers, we don't have enough, all right? So according to study that I did some research, a lot of literature review, and I realized that a lot of times students move or change their major from STEM because of math. They just cannot crack the math. There was like maybe to you guys, math is not a problem, but like a lot of biology major and nursing majors, they just cannot pass college algebra class. So this is what I decided to do. How about we do some evidence-based learning? Okay, so evidence-based learning. So for my case, evidence-based learning is using a JuliaBox and peer-led team learning. I will talk about the peer-led team learning a little bit later so you know what that means. So I believe if you do regular math class, I'm talking about college algebra class because that's the one I'm studying. That's the one that I researched. So in college algebra class, I'm going to use evidence-based learning. Then I believe if you do them together, when you then kind of combine together, infusion them together, then I believe it will increase their success rate. So what I did, the first thing I wanted to do is I want to train our faculty to how to use JuliaBox. And then we're going to train the peer-to-peer leaders, and then we will use a JuliaBox, and we also use iPad to doing evidence-based learning. So just like that, we purchased iPad through the NSF grant because I want to use iPad in my class so they can use JuliaBox in class for like their college algebra work. I wanted them to do it in class, you know, using a JuliaBox and start doing their college algebra problem. So why did I choose a Julia instead of anything else? Because we had a Mathematica, and then, you know, Mathematica is very expensive. So our department says, we don't have any more money. So we're not going to renew the JuliaBox. The Mathematica. And I was like, okay, then what can I do? So I did a little research, and then my husband said, hey, what about JuliaBox? You know, it's very easy to use, and I explored myself, and I really, really liked it. So I said, the reason that I use this one, basically it's a free, okay? I love that it's a free, that I don't have to spend money, nor I have to ask for money. And then also we use a JuliaBox that's a web-based, so we don't have to spend time downloading and trying to figure out, you know, whether it works for my computer or not. So we just stick with the JuliaBox. And it was very fast. Whatever we want to do, it was very fast. We really liked it. And it was very easy to use. Like, none of my students, just think about this nursing majors and biology majors. They don't program. They never know. They never seen programming, actually. Okay, this is their first time ever seen programming languages. And it's easy for us to look for something. Whenever we don't know how to do, we actually Google it. And then there's all the documentation about that things I wanted to do. So how I did with my faculty workshop. I did 2 days faculty JuliaVox workshop. It was very funny and required a lot of patience because I am not kidding. Because I was when I created my JuliaVox, I did it right away. Maybe because I have a Google account already, Gmail, so I just used Gmail and then I got into my JuliaVox. It took not even 5 minutes. With my colleague, it took me 2 hours. I am not kidding. I don't know if it's true or not, but my daughter just told me something about maybe because of maybe I was using a Safari instead of Google. Chrome. I'm not so sure, but some of my colleagues had Yahoo account and a Hotmail account. Okay, and then, but anyway, they used that email to create JuliaVox, but they never can verify. And I couldn't figure out why it's not working. So, we do different things, and then later on I was like, you know what, just forget this. How about we just create a Gmail account? so that's the next thing we did. We just created a Gmail account, that everybody have a Gmail account, and then we went into JuliaVox. And that's the time we start, working. But that was like a morning session. We spent the entire morning session creating a JuliaVox. Wow. I know, it's funny to you guys, but we had a great time, okay? Because we were trying to figure out what's going on. So in my faculty workshop, I'm not a really expert Julia user, okay? That's my disclaimer. But I enjoy programming. I enjoy learning different things, okay? So what I did, I was like, you know what, let's just go over basic stuff first. So we're just going to go over buttons, because I want them to know how to use buttons, and I also want them to know how to execute your cell. So that's what we did. And after that, we went over some basic math, like how to add, how to subtract, and all those basic stuff. And then we did a plot, the basic plot, because in your college algebra class, the entire chapter is about plotting. So we talk about that. And then graph transformation, we talk about this. This is the one actually on function transformation. We do this entire chapter about this. So I want to make sure that my colleague knows how to use this so they can use in their class. So all this, the faculty development Julia titles that I use is something related to college algebra class. Because I think about this and it's what do they need to know to implement in their college algebra class. So we talk about the basic function transformation. We also use a SymPy and linear algebra to do some variable calculations. So matrix calculations, we have done that. And then we do factor expressions and solve equations. So these are the basic stuff that I went over with my colleague for 2 days. I know you're gonna say, how can you go over this for 2 days? Believe me, it took me more than 2 days. And then we also met once a week, because my colleague need more support. Like whenever you learn something new, somebody needs to kind of help you, pull you, and then kind of push you. So that's what I need to do. So we did once a week meeting. So after every week, Monday 5 p.m., we meet an hour, just talk about how was your week? Did you get to use Julia? And then we also said, okay, what was your problem? So we went over that. So that actually helped them. But we still need more faculty development time, because that was not enough. Weekly meetings and 2 days workshop is not enough. We're still learning. And then how did I use my JuliaVox in my correct college algebra class? About the correct. Correct means we're trying to eliminate intermediate algebra class. So we're putting a student who making ACT score a 17 and 18. And then I put them with a person who make ACT score 19 or 20. We put them together. So we give them extra lab hour so they can jumping into college bearing class instead of intermediate algebra class. That's called correct college algebra class. So what I use in my Julia box, I use like a calculator. So I told them, don't buy the TI-84, don't need it. We're just going to use Julia box. It's a free. Whenever you don't have to spend money, they love it, right? So none of my students buy TI-84 or 83. We all use Julia box like a calculator. And then after that, we wrote functions.
And I like free stuff.
That's right. We love free stuff. So as I said before, mathematics is too expensive, so I have to find something new. That was Julia box, okay? And then actually my students actually liked this. They said, I feel like I'm learning better because by programming, you have to memorize your formula. Because like I say, you have to find a circle equation. We wrote a program to find a center point. And then we wrote a program to find the distance and things like that. So you have to memorize your formula to do things like that. And then they also liked it because they get to put this into their resume, say, I know how to write a program in Julia. So the Julia project that I did these are the ones that we did in class. So this is one of the lessons actually. Like when you taking college algebra class, you're supposed to find your center of your circle, and you need to find your distance, and you need to find, if I give you 2 points in a circle, then you need to find diameter of that. Like you do different things. That's what we did in 6 different stuff. So we did this in class together. We wrote it. I mean, the function is not hard. Just like you can see it, it's just like a 2-line or 3-line function, but it's just their function. We wrote it. We just use that. We plug in 2 points, and it spits out the center and spits out the distance and things like the radius and things like that. So there's more to the problems. And then this is our semester project. So I thought I want to do something they can relate to in their, like a consumer report, consumer math kind of type. I said, okay, use internet, use like a consumer, what's they call, consumer report or admin or a Kelly book, and find three cars in the same categories, and let's figure out what is the best car for the price per mileages. So we wrote small programs, and we did different things. We plotted, and then according to our calculations, we found, Kia optimized the best if you drive less than 20,000 miles. So anyway, it's something, it's a very little thing, but we did it as a college algebra student. So I was very proud, very proud. So student survey. So we did surveys so often because I want to see how it's affecting my students' learning. So students actually still very new to Julia coding, all right? But I realized the STEM majors actually enjoy programming a lot more than non-STEM majors. But my aim was anyway trying to increase STEM majors' performance. So I was like, this is still pretty good. It's okay. I don't get everything. Okay, this is the first try, so I don't expect everybody to increase their grade. Okay, so I was happy with my result that STEM majors doing better by using Julia. Okay, now it's about the peer tier. Peer tier it's a peer-led team learning. So it's like a tutoring session, but it's a little bit different because tutoring session means you're there and then people just come to you, right? The students just come to you, but it's not like that. So peer tier means you have, in my class, we create groups, okay? And each groups will have their own leader. The leader is not in that class. They're the one who took that class previously. So like my peer tier leaders are the students who took my class last year and who made A's and B's, who has a good personality, who can work with the students. So they become a peer tier leader. So they will meet my group of college algebra students beside the class. They meet like twice a week, maybe like 2 hours per session or hour a session. And they all go over homework problems, or sometimes they go over the worksheets I gave them. And also, PLTL leader is not a lecturer, and they don't usually give out all the homework answers, because I don't want them to do students' homework. I want them to be there to help them out and do their work. So peer-to-peer leader is more like a coach or encourager, a good role model and helper and mentor and tutor. So they actually make a group me of their group, and they text them so often, say, hey, have you done your work? Hey, don't forget to go to class. I know this is like a trivia for you guys. It was like, who wouldn't go to class? Why you have to text that? But you have to realize our school setting is not same as some other school. Like our student may need more push and help because they haven't maybe learned what they're supposed to learn in high school. So they're still learning that in college setting. So my peer-to-peer leader is kind of like my helper. They remind my students, hey, don't forget to do your homework. Hey, don't forget to go to class. Hey, we have a meeting tonight. Things like that. Such a little bit easier on me. Before I had to do all this, but now I have a peer-to-peer leaders helping me out. So that's how we increasing our passing rate. Because there's helpers I have. They keep telling their colleague, hey, peers, hey, we gotta go do this, we gotta do this. Such easier than I'm keep telling them what to do. And so peer-to-peer student survey data, as you can see, 65% said, I like this. Peer-to-peer leaders, I really like this, that you're helping me out with my learning math. And preliminary result, the evidence-based learning helped most of the students. But just like I said, most of the students, not everybody, okay? So we're still working on it. And the Julia box is definitely going to the learning curve, but the STEM majors liked the Julia coding, computer coding. And iPad was very, very helpful because you can just go to Julia box and start programming, start writing things, do your calculation like a calculator. And then the peer-to-peer was very successful. There's the peer helper, the peer motivator was very helpful. And that's my students using an iPad, doing their work. My future research, I'd probably like to collect more data, and with the STEM and non-STEM majors, how does it affect using programming in Julia? And I also like to use Julia more in my classroom. And then also, I would want to do more a pilot study in a correct psychology algebra class and how does it work. And I would definitely train more peer-to-peer leaders. And then I need to do more Julia in-house faculty workshop because that was not enough, what I gave them. And also definitely want to apply this to my calculus class because I haven't done it yet because right now I'm only focusing on college algebra class, but that's our biggest problem because we have so many biology major, nursing major, they keep failing. So I was focusing on them, but my next focus would be my calculus class. They're like physics majors and computer science majors and math majors. Because those people, they don't take college algebra, yes.
So I think someone posted less than 2 months ago that they've already written Julia-based introduction to calculus.
Yeah, I have that.
You have that?
Yeah, I've been looking at that. So actually, when you look at my code, the things, one of the website, we're referring to that.
Awesome.
So I'm not saying I'm going to create new lessons. What I'm saying is like how I'm going to use it in my calculus class.
And it's a good resource for your use case?
It was actually using because when I was doing a SimPy and a linear algebra, actually I was looking at his lessons, and then he used that. So I was like, you know what, I'm going to use that for my, what do you call it, expression, like simplifying expressions and things like that. Actually, I was looking at his lessons. Yeah, that was in my, what do you call it, go-to place. I look at that a lot, yeah.
Awesome.
Yeah. Yeah, but what I mean by using a calculus for the Julia means not really creating a new stuff, but I'm start using it in class, yeah. My acknowledgement, of course, the NSF and HBCU Targeted Infusion Project Grant, I received that in 2017. That's the reason that I get to purchase iPads and things like that. And then definitely thank you for Julia Computing Diversity and Inclusion Grant. So that's helping me out with my colleague with their funding. And then my husband, Stephen Harris, he is the one who told me about that grant. Otherwise, I wouldn't have that grant. So. And these are the references I'm talking about, about the STEM majors. We don't have enough STEM majors, especially minority STEM majors. This is all the research that, literatures. And any questions? And thank you so much, you guys.
I was very taken with the data analytics problem that you did on the sort of value of a car as a function of distance driven, because it goes for college algebra, it goes very deep in terms of the sophistication of questions you can answer. It really uses a lot of different features of Julia and all this kind of stuff, and it feels relevant to the students. So your problem design there, I was very, it was inspirational to me, so thanks.
Okay, thank you. I really hope some other school, I'm not so sure any of you guys were teaching a minority institution like I do, like HBCU, but this will help them actually, because like I'm like focusing on college algebra, but I know a lot of institutions doesn't cover college algebra, so it may not be relevant to you guys, but if somebody does, let them come to my GitHub account, Anna Lee Harris, a GitHub account, then you can see all the stuff that I put it in there.
Yeah, so I think this was a wonderful talk, and I would, I think you're right that many people here might not be teaching at a minority institution, but I think there might be many others out there, who do, and it would be great to be able to figure out how to get these materials out,
Right.
out to others. And I personally don't know what the right way might be, but I really loved a lot of the course design and
Right.
all the
I put all
experiences.
of my lessons, my college algebra lessons, in my Anna Lee Harris GitHub account, because I know it's not all programming, but I was thinking if somebody wanted to, I don't have my personal website, so I was thinking maybe that's the one that anybody can go there and then they can just download, right?
We're going to share these slides. So do you have a link to your GitHub account in your slide?
Yeah, yes, I do. And also, see, I didn't know about the GitHub classroom. If I knew, it'd be so much easier on me because, I literally have to go to their computer and look at their code because I didn't know they were doing it right or not. When Kevin talking about, GitHub classroom, I was like, that's what I need to use. So my next, so I will use it. I will definitely implement that next time, yes.
Thank you for your work. It's awesome. I was just wondering, with students, you probably have some students who are quite excited about working with it. What do you refer them as like their next steps or how to get more involved?
Telling the truth, it was first time when I tell them to do this kind of assignment, they hate it. Okay, it was like pulling their teeth. And then I say, okay, if you don't do this, you're not going to get 25% of your grade. So my weapon was their grade. So it's like if you don't go to PRT workshop, if you don't do your Julia project, you will never get an A because your high score you can get is a C. And then they're STEM majors. Their grade matters. They want to go to medical school. They want to do different things. The grade matters. So they did it. So ones who want to do more, that's the one that I'm trying to do more Julia in my other math. Like right now I have a college algebra only, but some biology major who need to go to medical school, they need to take calculus class. So hopefully I will do more Julia programming in my other math classes. Yes.
I love the material too, but I was wondering that you said that a lot of the math and that was stuff that they hadn't had in high school. Mm-hmm. And I was wondering then if this is geared at that level, that maybe it would be good also for younger, like my own kids, high school students.
I know. I
That it
thought
might be
about
at the
that. I
good
thought
level.
about that. Right. So that means I need to consume more of my time for my high school students. Like actually, my chair told me, "Hey, this would be great for outreach. Go to high school and do this." I was like, "Is anybody going to pay for this?" Because you don't want me to go out and do more work.
Well,
but that is really something I'm thinking about doing it because like. If I don't write any more grant, then I probably have more time. Then I probably go out and do more outreach. Yeah.
It's just that I think you got to get them young before they get
I think so too. I
JavaScript
think
and
so too.
Python,
Like
my
a lot
sons.
of time, my students having a problem because they never learn what they're supposed to learn in high school. And then you cannot pointing to high school teachers, hey, you never taught them. That is not true. Okay? Because I used to teach at high school. It's not that I'm not teaching, it's a class management problem. Like a lot of time you gotta spend time in class management. Like students there's students doing some kind of behavior problem, you gotta deal with them. Okay, so like some people, I heard so many people keep talking about like high school teachers never teach right things or they don't have a criteria or whatever. Maybe that's true, but that is not entirely true, A lot of time it's a class management. You got students that you cannot really manage well. Okay, so yes, if I have spent time and spend more time and go to high school and students who want to learn, that'd be really good. Yeah, I am thinking about that actually. Yes. Any other questions?
Not a question, but were you able to manipulate macros in your lesson plans to use like sliders?
No, I have not.
Okay, so you will be very, very glad to learn what they are.
Okay, slider, okay.
We can talk about it.
All right, that's good. All right. I'm learning a lot of things from this right now. I learned about classroom and all this. Yeah.
Interact is probably the best tool you could use with Julia.
Yeah, definitely talk to me, okay, after class, after this. All right, thank you.
So my name is Elwin van het Wout. So you pronounce it as van het Wout, my family name. And I'm going to present our project, which we did at the Pontificia Universidad Católica in Chile, in Santiago de Chile. And it's actually about high school. So it's a nice question. And this project is... so the map is not showing. Okay, so it should have been the world map over there, because the most frequently asked question I get is, where are you from? So I'm Dutch, so I did study in the Netherlands. You need to figure out where the map is right now, but the small dots, they do actually show up at the screen. I don't know why it doesn't show up. And the dot next to it is London, and that's where I did my postdoc. And now I'm at a different part in the south, in a beautiful country called Chile. It's in the far south of the American continent. And I'm an assistant professor over there in the Mathematical Engineering Institute. So my project is about creating a workshop for high school students, and mainly from underrepresented high schools in Chile. So I want to start with presenting a bit of background about how the education works in Chile and why we try to target these high schools. So it's not very different than in many American countries in the American continent, or in Europe as well, or other parts of the world. So they have primary, secondary, and higher education. And the major difference between different schools are in how they get funded. So there are 3 different types of schools in Chile, and now I'm referring to the primary and secondary education. The higher education is slightly different. But for the primary and secondary education, you can distinguish between the state schools. These are free for the students. There are also private schools, so they are privately owned or managed, but they are managed and regulated and heavily subsidized by the government. So they are, for practical purposes, more like state schools, but with private owners or management. And there are the private schools that are fully financed by tuition fees by the students. In the case of higher education, the admission towards higher education is typically based on entry-level tests. So there is a nationwide entry-level test for the university, and the higher you score on this test, the more likely you are to get admitted to the better universities. And the universities typically do charge tuition fees up to a couple of or several thousands of dollars a month. No, not a month, a year. These are annual tuition fees of several thousands of US dollars. So at my university, at the Pontificia Universidad Católica de Chile, this is a general university, so they have all different fields. So if we look at the population of the students, you can see that the gender equality is around 50-50, male-female. So this is at the entire university. So far, so good. So the other thing I would wish to present is data on where do the freshmen come from? What kind of high school do we attract? So the university, my university, the Catholic University, is one of the best universities in Chile and Latin America, and also charges relatively high tuition fees. And you can see that the orange bar are the freshmen that come from private high schools. So the private high schools, we attract around 60% of the students intake are from private high schools. Just to give you the nationwide numbers. So only 8% of the total population go to private high schools, but we do attract 60%. So the private but subsidized high schools and also the state schools, they are heavily underrepresented at our university. And these are numbers from my university, but this, I think, is a case for many different universities in Latin America, North America, and other parts of the world as well. Perhaps in Europe it might be different because there are different education systems. So if we now do a zoom in at the School of Engineering. So we have a School of Engineering which attracts around 750 undergraduates a year. And the regular admission, so there are different types of admission. The regular admission is purely based on these entry-level tests. So they have this nationwide entry-level test, and the best student, they just take the top number of the students that apply for the university. And you see that engineering, the number of male is 71%, 28% female. So it's worse than the overall university. 28%, it's not that bad if you compare to many other universities, but it's still lacking behind the amount we wish to attract, the amount of female, or actually the equality in gender participation at the School of Engineering. And also the number of students coming from the private schools is even higher than at the general numbers of the university. So this, well, there is room for improvement for sure. And there have been many programs at the School of Engineering to improve the diversity of the student population. So in 2011, they started with a program that's called Talent and Inclusion. In Spanish, so it's a Spanish-speaking country, Talento e Inclusión. So this is a different admission type for the first-year students applying for the university at the School of Engineering. And this admission is based on relative numbers of students compared to their peers at their own high school. So these are the top students of their high schools, but not necessarily the best students countrywide. So they are better than the peers at the high school, but they might not reach the threshold for the overall intake. And this scheme has been very successful. So I do not have the accrued data, but you can see that the first-year grades of these students from the special admission, they are indeed lower than the ones from the regular one. But after 1 or 2 years, they already level out. So after 1 or 2 years, these students do as good as the regular students from the admission. And an additional side effect that is very interesting is that the amount of female students has also increased via this admission. So this admission is special admission based on relative ranks from the schools, actually increased the number of students. And right now, the number of female students at the first-year engineering program, we have reached 37%. So it is quite good. Still 13% lacking for the real equality of gender. So, and I also want to emphasize that there's actually a wealth of different types of initiatives. There is a peer group of women in engineering. There are scholarships available from both university and the government for underrepresented students. And there are also summer schools for teenagers. So, yeah, if there are already that many initiatives, what can we add to this? And I think there is a responsibility to add more, to do our bit as well, to increase diversity, to improve inclusion at these at the university, at STEM education, and especially because in computer science, but also in applied mathematics. So I have a joint department between mathematics and the engineering school. The data is worse. So I do not have the data, so I can't present it, but it's worse. We know that it's worse. And apart from gender diversity, I also want to emphasize the diversity on socioeconomic background. So the socioeconomic background has also an impact on the diversity, the student intake, and also on the inclusion of people from a different neighborhood, from different social background, from different economic situation in their family. So I wanted to take my responsibility as well and do just my small bit for the diversity and inclusion, and I applied for this for this grant from Julia, with the idea to start early, to start introducing programming early to the students already before they arrive at university. So the idea is to create workshops for high school students. So let me see. Yes. So the proposal was to design a new workshop type for introducing students to programming with 2 parts. So the first part would be at the high school. So we are going to the high school to present what is actually programming, why should you bother about programming, and some kind of introduction, perhaps with a laboratory if there is sufficient time, but also just explaining what it actually means to program. And the second part would be a visit to the university so they can see the campus, and also to use the laboratories at universities. And we use the funds for the transport for the organization of these workshops. And there are 2 main goals of it. So one we have been talking about is improving diversity, but I also want to stress out there is also a different goal, even if those students are not going to a university or to a STEM field. It is a very good skill to know about programming, to have learned about programming, especially for the future workforce. So, because, I mean, more and more need for engineers, for computer scientists, for programming skills on every level, not only experts, but also users of programming languages. So we also have this goal of providing these opportunities equally to all students, high school students in our country, Chile, to learn about programming. And why did I choose Julia? Or, well, one was because of the grant. The other one, and perhaps more fundamental, is it's free, it's intuitive. So for these first experiences of the students, it has to be intuitive. We can't start with compiled languages. It has to be intuitive. With Jupyter notebooks, they are very well suited for teaching programming to first-time users, and also because it's free, so we can't afford to pay licenses for the software. And I also want to emphasize the Julia box. So we're using Julia box, which is very well suited, because you don't need to install it, you don't need to have a computer, because you simply cannot assume that everyone has its own notebook computer. So you can use it on all different devices you have for free. So we didn't have experience in this before, so we started from scratch, and I had the help of several undergrad students from our mathematical engineering major, and we started to design teaching material. So we looked on the internet, is there actually material available? And for teaching basic programming, there is actually quite a lot of material available. Already on Julia box, there are many tutorials, very basic ones, but very intuitive, very good, well-designed first tutorials for programming, and actually also in Spanish. So in the Julia box, there is also a Spanish version of the tutorials. I'm not sure who actually made, you made it, or you translated it. Well done. Well done, yeah, because I need to have all the materials in Spanish. So okay, wonderful. Oh, that's very good. But the more, the challenge was actually finding interesting and motivating applications, because the first question, well, a question you have to respond is, why programming? Why should I bother about programming? What can I do with programming? And that's more difficult to find on the internet or in books, or basically boils down to my own experience as a scientist in my own research projects. But then I have a very limited set of applications to show. So that's still a challenge, and we're trying to improve it. So actually we designed a Jupyter notebook. I was thinking what is close to the reality of the people in Chile, and there have been quite a lot of wildfires in Chile, so forest fires. So I thought, why not use random forest to predict forest fires? So we created a small tutorial of using random forest classifiers, how big the wildfires are compared when there's different temperatures and so on. There's actually a data set on internet. We found a data set on internet. But it's still a challenge. And actually, an even bigger challenge was to get high schools participating, because they don't have to participate. I mean, it's not a part of the curriculum. Programming is not part of the curriculum. So why would they spend some time on organizing it, or actually they don't have to organize much. They just have to open doors and we will do the organization. But even responding emails is already too much to ask for many high schools. So we partnered with a organization which is called Enseña Chile, or Education Chile. And this is a non-governmental organization that tries to improve and give education to all the people in Chile for equal opportunities and create a more inclusive Chile. So we partnered with this organization who provides education materials and teaches professors for high schools on every subject, not only program, but everything. And then so they helped us finding and communicating with the high schools. And yes, still there's a low response rate. The main question is the teachers and administrators already have a very high workload because of low governmental funding. And also, they don't know anything about programming. So if someone asks, let's do a program, but you don't know about what program is, then it's easy to deny these opportunities. So right now we are collaborating with a high school. It's called the Colegio Polivalente San Pedro in Quilicura. And it's actually very interesting what they have over there. So over there was one high school student, very interested in programming. So he learned programming on himself with actually another event at the university. He learned programming, the basics of programming, and he was so excited. So he invited his peers, his other students, and said, well, I can teach you also programming. So they are gathering every Thursday in the afternoon for 2 hours. So they're teaching each other. And so we're trying to help them out as well. So we've given one of the workshops at this school, and they will be visiting us very soon in the university. So there's a very interesting situation where actually there is a need, there is interest from students, but there is no teacher available for them to teach programming. And actually they also invite students from neighboring schools as well. So this is the project for Julia. And when I was working on the project, I also had regular teaching duties. So I had to teach a course on what is as a part of data science. And I got interested in, I had to find a data set for an assignment. So you will find somewhere on the internet a data set and you will explain how clustering works. So that's the basic workflow for a professor. So I was thinking, how can I include also diversity, of awareness of diversity in the programming tasks I have to assign anyway. So I think also about awareness of diversity is not just about creating different projects just for diversity, but including it in how we think as professors. We have to choose examples for programming. So why do we choose this example, not the other one? And then we already had a small discussion on this. So how do I choose a example that is actually interesting for all of my students, not just for me or for a small group of my students? And that's actually an open question I still have. So any feedback, any ideas on this, very welcome. So actually I had found a database on internet from the Chilean Ministry of Education with all 10,000 programs in higher education. So it's a database in Excel sheet with 10,000 rows, or almost 11,000 rows, and the features include things like what kind of degree it is, how high are the tuition fees, also the gender diversity, the percentage of high schools, different types of high schools. So quite a lot of data. So I gave them 2 examples. So this is the same data set, the same variables, the same clustering. But you can see these clusters are quite different. So now the question is, why are these two clusters different? It was one of the questions at the assignment. So hopefully, perhaps you can see it. So we have on the horizontal axis the tuition fee in Chilean pesos, and over here the percentage of people, of students coming from the private education system. And here is the same variable, but now it's normalized. So you see over here distances, 9 million pesos, and over here is between 0 and 1. So here is between 0 and 9 million pesos. So 9 million pesos is around 13,000 US dollars. And if you normalize it, for sure the clusters look very different. So this was just a small assignment for them to understand clustering, but you can also clearly see a bit of this diversity we're talking about in education. So the higher tuition fees, there is a bit of a trend of programs that charge quite a high tuition fees and a high percentage of people students from private education. So it's not a very clear trend, but you can see the trend, and there are some more. At least it creates a bit of awareness that there is actually a trend between the secondary type of secondary education and the tuition fees you can afford, or actually are willing to pay. Let's say this. So to summarize it, so we designed a workshop for these first-time users in programming, mainly aimed at underrepresented high schools in Santiago de Chile. And in next semester and also next years, we wish to include more schools. So we are in contact with more schools, but it takes time to get them motivated to really participate in these workshops. And meanwhile, I'm also interested in trying to get some materials or train the tutors, the peers, or teachers at the high schools, and improve the teaching materials. So for the basic programming skills, it's relatively okay with an amount of examples, but for really the motivating, interesting examples, that is a bit more complicated. And meanwhile, I'm trying to find out how to include this awareness on diversity also in regular tasks as a university professor. So that's it for my project. Thank you. Are there any questions or remarks? Kevin.
So you mentioned that you're starting to think about spreading this or getting the high school teachers involved. Have you seen much interest in that? Because obviously you can't go all over Chile to do this. No. So it'd be really great if you can sort of scale this up by getting the high school teachers into it. Are you seeing any interest in that?
It's difficult to get interest, yes. So on a large scale, it will be very complicated in the near future. I'm for sure that's correct, because these teachers at high schools, they have their own curriculum, they have their own tasks, so they're already quite overburdened with the things. So it's difficult to do this at large scale, but I'm definitely trying to start at a lower scale at the high schools we already have contact with, and try to motivate them. So step by step, if they see that the students are actually interested and they are already starting on their own, why wouldn't we also try to educate the teachers or give them materials so it's very easy for them to educate? So hopefully with small steps we will get a bit more penetration in the high schools, yes.
So, gracias. Thanks a lot. What was your experience with teaching high school students with starting with the Julia box tutorial? What's the sort of feedback that you could give, because like there should be a revamping of that soon that I should do. So any and all feedback that you have is very much welcome. And just as a side comment, like if you're interested in having videos for that, there's actually a recording I did just running through that whole tutorial in Spanish. It's on YouTube, and like I didn't realize this, but it has like almost 5,000 views now. That's a lot of people that I didn't have to teach myself. Which is like I had no idea that you can be like, oh, like that's a lot of people, or maybe it was just like random clicks or bots or whatever, but it's on YouTube, no? And so like there's stuff that you don't get to cover individually in class because some people are like running around or something's on fire, no? But like being able to like have like, oh, if you want to see a person do this, no, like there's a video archive like just solving this, no? Like that's so second question. First question would be, what's the sort of feedback that you have on the Spanish tutorial and any and all wishes? And second of all, like, how, if at all, do like video tutorials help students? That's it.
Yeah. So we just started with this workshop, so we do not have any questionnaires or really feedback from a amount of students sufficiently large to really say something about the feedback. But I also, with my personal experience with the tutorials in Spanish, so there's a lot of information in English about Julia. In Spanish, it's limited, but the Julia box, and I wasn't aware of the YouTubes actually, but I will try to find them on the internet, or actually we should talk afterwards. It's actually very well made. So you see the basic steps of getting into in what is actually programming, the first steps of just defining a variable. And I found it very intuitive, these tutorials. And my experience also with the students at the university is that they actually look for YouTube movies, not really for books or for texts. And that's why I'm quite interested in these YouTube movies as well, because that seems to be more related to the reality of the younger students, because they are more in visual, clicking on their iPhone than really reading a book. So I think they're very good. So were both questions, or I forgot the second one.
Yeah, it's like what? So yeah, you answered it. Like
Yeah.
more video stuff.
Yeah. No, I definitely think the videos on YouTube are very worthwhile. Yes, for sure. Yes. So, if there are no more questions, I want to present one more project, actually not my project. So, there was another project from Graciela Igano in Brazil. And she couldn't make it over here, but she sent some slides, so I will present her project. Hopefully, I will do a good job in presenting her project. So, in Brazil, Brazil is a very large country, and the major universities are concentrated in the more southern part of Brazil, where you have the bigger cities and also large universities. And in the regions, further away from these larger cities, there is not a really penetration of Julia or actually programming in general. So she decided to create also kind of workshop or a study group, where she invited colleagues, and I think it was an open invitation to everyone interested in participating in study groups in two different cities, in Goiânia and Maceió, which are different locations in Brazil, quite far away from the major cities. And for a couple of weekends in last April and also in May, they gathered at a university or a center to work and learn Julia. So they started tutorials. They also used, so they used Github and also Slack and Telegram channels. And together they had they had 16 participants in Goiânia and 14 participants in Maceió. And interesting is she managed to attract 2/3 of women to these workshops or study groups. So that's very good news. So she also asked about kind of race, so mainly white, but more interesting as well is they came from different cities in the region where they organized these study groups. So that was the main focus of our group, to expand also the notion of programming and learning Julia in different regions in the vast country of Brazil. And she provided also financial assistance for participants who require this. So it's a very interesting project Graciela did in Brazil. So also very much thanks to Graciela for her projects, and she couldn't make it over here. For the final project of Henry, we didn't receive any slides, so but I'm convinced that he did a very good job in creating a MOOC as well. So with this, we want to finish the presentations, and we also like to invite people from the audience if you have some suggestions, experiences in diversity, inclusion, or other comments. It's very welcome to use the microphone, or if you have more questions to one of the presenters, welcome to participate. So are there any, Henry?
I'll type them up. Just add them to the slideshow here.
So actually, it's more of a comment for you guys. It's not, this is probably a very small thing, but if any of you speakers, and maybe others who are ever in Silicon Valley and want to repeat your talk to our little users group, would love to have you. It's where we have it's a pretty, not a very diverse group, and would love to have more. So it's, of course, that's a small thing.
I grew up in Santa Cruz, so when I go home, I'll reach out. Yeah.
Great, please do so.
Cool. Anybody else have thoughts, suggestions, ideas?
I was just going to say, so, is there a forum for sort of, sharing best practices or things like that? Is that something that we can think about doing as a group? Because we'll all go away from here, but if it's something we want to keep working on, it might be a useful thing. So
well, there is a diversity channel on Slack that has. I don't know if I would say a lot of subscribers, but it has a non-negligible number of subscribers. So, yeah.
So there's a non-focus is a gender and diversity inclusion booklet where they signal not only like code of conducts for conferences, but they also try to do some introduction to diversity initiatives and producing materials.
So there's non-focus. What's that called?
Focus handbook that I've translated into Spanish if people are interested. And so, like, since it is under the non-focus umbrella, I know that for sure that Jane Harriman has had, like, some work with
Cool.
integrating that.
That's excellent. I don't know, in terms of having like a place to collect resources, I think that's a great idea. Sorry, I'm trying to do two things at once here. My preference personally would be to try to use the forums that we already have, like Slack and Discourse. So I don't know if there's a Discourse. Can someone tell me which of these is the bulleted list? Because I can't actually see. That one? Okay, great. So I think using Discourse and Slack would be a great way to aggregate that. Does anyone know if there's a diversity topic header in Discourse? I don't think so. So maybe we can ask the powers that be to add diversity topic.
my guess is you'll be up in 30 more seconds or so, right?
All right. Thank you for that. So we can do a little check mark. Cool.
Oh, okay. All right. Oh, very good. Okay. Yeah, just to speak, I have a couple times dipped into Slack, but the volume is way too much, and Discourse is much better for sort of posting documents
Definitely.
that have legs to them that you want to go back to again and again. For one thing, it doesn't expire if you haven't been, monitoring it, right? So I would definitely ask.
If it makes you feel better, this is the number of Slack channels that I'm involved in.
Yes.
So, this is Julia, but then I also have, you know, a bunch of others workspaces that I'm in, which is gets a little crazy. Anyway, cool. Yeah, so that's great. I think definitely aggregating resources. There's a problem. There's sort of the problem of collecting the resources, but then there's also the problem of getting people to come to the resources, right? I think probably most people in this community, my experience has been that if you bring up topics on diversity and inclusion, everyone is supportive. Like, I haven't seen much pushback in terms of like, no, this is stupid, we shouldn't worry about this. I think everybody thinks we should worry about this. But, okay. At least there's not active resistance that I've seen. But there is the problem of, okay, well, you could share with us. I haven't seen it, but of course, you know, I probably wouldn't. But beyond that, there's also the problem of, even for the people who would in principle be supportive, they're not spending most of their time thinking about it. And so getting these issues in front of people and keeping it on the front burner, I think is also worthwhile. So I think collecting resources is good. We should also be pushing those resources in front of people to the extent that we can.
So in terms of teaching resources, we at Julia Computing have been working on this Julia Academy platform, trying to figure out what the best fit is for us and for the community. And over the past few weeks, we've been talking about it and been thinking about completely opening it up as a free platform. We had been thinking of doing it as a paid platform, but if it's a free platform, then we can more easily accept contributions from outside teachers, and we would love to have all of your materials on that platform, so then that can become a central place. Also working on a central place of best practices for teaching as well, not just for, you know, teaching others, but teaching teachers and sharing amongst ourselves. So I want to connect with all of you at the end
Definitely.
here to
That'd be great.
figure out how to best set this up online to make it easy and accessible and available to everyone.
And translated into other languages.
Ideally, yes.
Yeah, cool. And I think, you know, in terms of targeting different groups, there's the gender aspect I talked about, there's the minority aspect that Anna talked about, and then there's the socioeconomic aspect that Elwin talked about. And I think all of those, you know, some approaches will work for all of those groups, and some approaches are going to have to be targeted at different groups. So I think having free Julia Academy would be great for especially that last, making sure that it's available to everybody. So, yeah.
Great talk, everyone. I have more of a comment instead of like a question. From the gender standpoint, as a female CS major, I feel like the biggest obstacle I have is not having any female mentors. And I know a lot of females have imposter syndrome and feel like, oh, I'm not in a place where I can mentor other people. But we really do need that. And so I feel like encourage your female colleagues to, you know, step up, because they really are worthy, like, and other females need them. So just talking to a small audience here.
There's a giant audience on YouTube, so yeah, I think also, and I don't want to hog the mic. If you guys have thoughts, please push me out of the way. I'm typical American man. I just take the stage. But I think mentoring examples not only for women, but also for minorities, also for people from different backgrounds, all of those things is definitely important to see examples of people that are like you doing a thing to make it seem more possible. And also I think there is definitely I think it would be great to have more mentors, but then there's also this problem that's been studied. This happens to women and minorities, at least in American institutions, where you have the small number of women and minorities, and then they are asked to be on all of the committees. They're asked to do all of the mentoring because they're the few examples. And then, of course, they can't get their own work done. And so they don't advance as far in their field because they're being asked to sort of shoulder this giant burden. So those of us that are white men should also be making sure that in our mentoring, we are actively promoting our underrepresented colleagues, that we are avoiding all those biases that I talked about. It's very hard. You have to be mindful of the fact that you're not only calling on the men in your class. So I definitely think that having more mentors is great, and we should work towards that, but also the rest of us need to work on it. So. Any other thoughts? We're actually coming up on the end, but I would love to go out for beers after this, so if anyone wants to buy me one, I'm happy to talk about it.
We're actually talking about diversity and inclusion.
Sure.
So if we're talking about diversity and inclusion, there's, in particular to JuliaCon, at some point you have to consider that if you want to go international, worldwide, and inclusive, including non-alcoholic events, not only for people who are alcoholics or is trying to stay sober, but that come from religions that don't partake, including events in which alcoholism is, alcohol consumption is considered to be the social norm. That might also deter parents who bring in children. There's JuliaCon access considerations. So that like there's a big staircase here, but we have elevators, or have assuring that you can have parents scholarship for parents so they can bring along toddlers if they can't leave them, or if it's going to be at this venue, making sure that there's family friendly restrooms where they can change to their children, or all of those things take a lot of work. They're not insurmountable, but you have to know they're there. No?
Yeah, absolutely.
And
that's a great, thank you for bringing that up, and I apologize for that. I think you're absolutely right about that.
I will surely go for beers, but no.
Yeah,
but including spaces which don't expect consumption of alcohol would just in general be healthier, no, for a lot of it's a discussion that can be included and would be compatible with a healthy community, and then people will normally break out into whatever it is they want to do, but not having
that be part of the specific event.
I am really glad you talk about that, because I don't drink because I cannot tolerate alcohol. I don't have enzyme to break the alcohol, so I literally drink one wine, half glass of wine. I just go to sleep. So, there's no way I'm going to have a conversation, right, if I go to sleep. So, non-alcohol conversation would be actually really good for me. Yeah, definitely.
I don't know how quite to phrase this, but I'm trying to capture components. So I think speaking about there's the large groups of diverse populations, and then there's a bunch of stuff that often we don't consider, such as religions that have different considerations or accessibility.
Sorry. I think Omaripo has a consideration for if you're a different type of colorblind.
Yeah.
So that, the keywords will come up with a different colorblind schema that will actually work for you.
Yeah, and that would be great. There's also the Color Brewer package, and Color Brewer is a library of colors that are specifically designed to be accessible, both in terms of color blindness. There's the color blindness where I can't remember all the exact terms, but it also has sort of ranges of hue as well as brightness, so that even if you can't see color at all, you can still distinguish. So there are things like that, and I think it's definitely worth thinking about those.
Just one other comment. I recently served on an NIH panel that was awarding grants partly to cover conferences. And one of the main criteria that they use in evaluating those grant submissions is the child care, how the quality of child care facilities. And I suspect that's something extremely difficult for a volunteer-run conference where we're trying to keep costs down and all that kind of stuff. But in terms of sort of moving forward, and as the Julia community starts growing, we may want to actively seek ways to help provide funding for people who need to bring kids in order to attend, for example.
Yeah, it's a really great point. And that comment reminded me that there was a discussion on Slack several months back about getting captioning for all of these live talks, for people who have hearing impairment. And, again, that's a cost issue because it takes a lot of money. And translating them, absolutely. So there's a number of things that are sort of labor-intensive things that could potentially be cost prohibitive, but would be great if we can work out ways to fund those or, get volunteer services to fix those. But yeah, totally. Yeah.
The gentleman just said at a conference, maybe you can apply for the conference grant. So we can help pay for like daycares and things like that.
Yeah. Worth highlighting, yeah. Cool. All right. Well, thank you. Thank you all for coming, and we'll go out for a Virgin Bloody Marys if that's the.